In this video, we are examining the equations for hyperbolas, horizontal and vertical, and looking at the visual patterns that exist in them to help us better understand how to graph. So first off, let's start out a little bit different than we did for the ellipses. Let's look at the equations first to see what is the difference in the two forms. And so I can see right away that when we're looking at a horizontal hyperbola, the x minus h squared comes first. But yet when I'm looking at a vertical hyperbola, the y minus k squared comes first. So that's the first key. How do I tell if it's a horizontal versus vertical hyperbola? And it's based off of which comes first, the x minus h or the y minus k. So that distinguishes between horizontal and vertical. The next part you want to look at is, well, what else is different? And really, besides the numerators trading spots, everything else is the exact same. A is always under the first numerator. It doesn't matter what the size of A is, it's always under the first. And there's a reason why. And that's why I have these pictures here. So this is I'd say the big difference between ellipses and hyperbolas is the A value is constantly the denominator of the first fraction for hyperbolas. For ellipses, the A was the largest number in the denominator. But the reason why A stays where it's at when you're dealing with a hyperbola is because A we've defined as the distance from the center to the vertex. And so A is moving left to right to create those vertices for a horizontal hyperbola. So therefore the A for a horizontal hyperbola has to be under the x term. And we can even look at it the same way for this vertical. Here's our center. Here's our vertex. A is the distance from the center to the vertex. Well, now that A value is going up and down. So it has to be located under the y. So the big takeaway is a squared is always the denominator of the first fraction. The only thing that switches is the numerator of the first fraction and the second fraction on which one comes first, the x minus h or the y minus k. But that is also why in the previous video for ellipses, I say it's more about concepts. A is always defined as the distance from the center to the vertex. That is a concept that goes no matter which one you're dealing with, the ellipses or hyperbolas. It's always the distance from the center to the vertex, which is why A has to be under that first fraction for hyperbolas. Now, the transverse axis just is it a horizontal hyperbola or is it a vertical hyperbola? Which direction is it opening on it? Center is still HK. Let's skip asymptotes for a while. And the same idea holds to be true. Is H and K is the center, and notice all the important parts have the H and the K inside their formula. So I'm going to want to plot the center first and then start using my visual patterns or the formulas to move and find all the other points from there. Now again, we've already covered it, but A is the distance from the center to the vertex. So notice I'm adding and subtracting A to the H value, which is the X value, which moves me left and right, which creates the horizontal hyperbola. For the vertical, notice how A is being added and subtracted to the K value. So that's just moving me up and down on it, which creates the vertical hyperbola. Now here, the focus is located just like it would be here. It opens up towards the focus on it. And for vertical, the focus would be here around and the focus would be here. So the hyperbolas open up towards the focus. The focus are going to be further away than the vertices from the center. But again, the foci are located on the same axes as the vertices. So we're adding, subtracting C to the h value. We're abstracted c to the k value. And we define that even for ellipses. We said, hey, c is the distance from the center to a focus. That definition for ellipses is the same definition for hyperbolas on it. And so that allows us to use one concept to go through both of them. So we have that, and that's why you're adding, subtracting the c to the h, is because the foci are on the horizontal. And on this one, we're adding, subtracting to the k because the foci are on the vertical for it. Now, to find c, it's a little bit different. This time it looks like the Pythagorean theorem, a squared plus b squared equals c squared for it. So we have that way to find the c value this time. Now, the one part that is different, we have asymptotes. Now, you're tempted to think that hyperbolas are parabolas, but they're not. When you sketch a hyperbola, they approach the asymptote. As you get further and further and further and further away from the vertex, it turns, I would say, more linear. It doesn't have as much as a curve to it because it's going to approach the asymptote here. So the asymptote, we have these two for the slopes. Now, the part that's missing on this formula sheet, it's on yours, so I'm going to put it on here, is the equation. We're going to use point slope form. Y minus k equals plus or minus b over a times x minus h, or y minus k equals plus or minus a over b x minus h. So what do we see pattern-wise here? Well, we can see it still has the y minus k, the x minus h, just like the top numerators of the standard equation, so that's easy to do. We're given those for it. The only part that we're not given then is, what's this? How do I know plus minus b over a or plus minus a over b? Well, one, you have to know what type of hyperbola you're dealing with, horizontal or vertical. So like this is the key. And it really is. It's this idea of thinking for a moment. Don't rely heavily on the formulas. Understand the formulas. You have two options. You either have plus or minus b over a, or you have plus or minus a over b for your slopes. Those are your two options. Well, if I can remember a definition, then I can know which one is which. And my definition that I'm asked to remember is slope is rise over run. And the reason why that's important is because we know that A is the distance from the center to the vertex. So in this case, your A value is a run, which means this should be the slope for a horizontal hyperbola. And if I take a look, it is plus or minus b over a. My distance from the center to the vertex is a run. And in this case, my A is a rise. So my distance from the center to the vertex, I'm going up and down. So that should be the slope for a vertical hyperbola, and it is. So if I can remember the definitions of what A stands for, the distance from the center to the vertex, that can help me very easily understand, is it b over a or a over b for the slope of the asymptotes. So this is just meant to kind of show you some of the visual patterns. A lot of them, if you understood the visual cues for ellipses, are the same for hyperbolas on it. If you have any questions, please do not hesitate to ask.